Hello students, now let us continue with one of the important problems that has appeared already in your previous year question paper, that is solve 4d to the power 4 minus 8d cube minus 7d square plus 11d plus 6 of y is equal to 0. Okay, so you have to solve, this is a homogeneous differential equation. This d means it's already told to you that it is d by dx. Okay, so minus 8 d cube minus 7d square plus 11d minus 6 is plus 6 of y is equal to 0. Okay, so let's start with the solution. Since the equation is already given in the standard form, I mean the f of d is directly separated form, so d to the power 4 minus 8d cube minus 7d square plus 11d plus 6 of y is equal to 0. This is the given equation to you. Now replace every d by small m. So it will be 4m to the power 4 minus 8m cube minus 7m square plus 11m plus 6 is equal to 0. So you get your auxiliary equation like this. Now once you get your auxiliary equation, now you have to solve for the values of m. Okay, you will have 4 different values for m here because the power for the auxiliary equation is 4. Now by inspection method, I'll just check for some values of m. Okay, so if I put m is equal to 1 in this, it will be 1 means it will be 4 minus 8, is it not? 4 minus 8 is minus 4, minus 4 minus 7 is minus 4 minus 7 is minus 11, minus 11 plus 11 gets cancelled, you have still plus 6. So m is equal to 1 is not the root. Let's check for m is equal to minus 1. If you take m is equal to minus 1, it will be wherever it is even power of m, you will have positive value for m. I mean, if I am putting m is equal to, just a minute, no, wait a minute. So if I am putting m is equal to minus 1, what will happen? It will be 4 into minus 1 to the power 4 is plus 1 minus 8 into minus 1 to the power 3 is plus, sorry, here it is minus, so minus 1 whole cube is minus 1, so here it becomes plus, minus 7 into minus 1 to the power 2, it's plus 1. Okay, so I need not do anything, but when you put m is equal to minus 1 over here, it becomes minus 11 and plus 6 as it is. Add all the numbers, it's plus 12 plus 6, it's plus 18, and minus 11 minus 7 is also minus 18. So this is plus 18, this is minus 18. You are getting it to be 0. So m is equal to minus 1 is one of the roots. So therefore m is equal to minus 1 is the root of the given equation. Okay, is one of the root, I'll write, is the root. Okay, by inspection I'll write, that's enough. Okay, now let's go by synthetic division to find the other roots of this equation. So for that, what I will do is I'll write all the coefficients and divide by one of the roots. So 4 minus 8 minus 7 11 and 6. You have minus 1 as the root, so first 4 you should write the same here. Now 4 into minus 1 minus 4. Now this if you add, it becomes minus 12. Minus 12 into minus 1 is plus 12. Plus 12 minus 7 is plus 5. Plus 5 into minus 1 is minus 5. Minus 5 plus 11 is plus 6. Plus 6 into minus 1 is minus 6, and adding this you have 0. So you get the equation of the new equation, the coefficients of the new equation, something like this. So since the previous equation was of degree 4, now after dividing with one of the roots, the new equation what you get, it will be of degree 3. This should be the coefficient of m cube, m square, m and a constant. So you have 4m cube minus 12m plus 5, 12m square plus 5m plus 6 is equal to 0. Now once again, I'll just put m is equal to 2 by inspection once again. Let's go for m is equals to 2. If I put m is equal to 2, it will be 8. 8 into 4, 32 minus 48. That is too high. Okay, let's put m is equals to minus 2. if I put 1 minute, m is equals to 2, I think we get 0. 1 minute, 4 into 8, it's 32 here. Yes, put m is equal to 2 in this. 4 into 8, 2 cube is 8, so 4 8s are 32, minus 12 into 4 you get, 12 4s are 48, plus 5 into 2, 10, plus and 6 here. So if you add, it is plus 32 plus 10, 42, 42 plus 6, 48, plus 48 minus 48, it is 0. So m is equal to 2 is the root of this equation. So what I will do is, instead of writing this equation, I will once again take the same coefficients. Anyway these coefficients are already written here, so I'm going to directly divide it by 2. Just see, you can do it here itself, no need to take another this. So m is equal to 2, I have got the root. So we'll write 2 over here. By inspection, m is equal to 2 is root. Okay, so if you divide, it will be 4 as it is. 4 2s are 8. Adding these two, you get minus 4. Minus 4 times 2 is minus 8. Adding these two numbers, you get minus 3. Now, minus 3 times 2 is minus 6. Adding these two, you get 0. Yes, so you got this as well. Okay, so you have got the new equation. So now first equation we divided with one of the roots, you got a cubic equation. Once again you divided the same coefficients by another root, you should get the quadratic equation by now. So it will be 4m square minus 4m minus 3 is equal to 0. Now you should write the, yes, now you have to factorize and simplify it. It's very simple. So you have to find the factors of 12 in such a way that the addition of 2 should be minus 4. The two roots when you add, you should get minus 4. So 12, yes, 6 and 2, yes, minus 6 and plus 2 you can take. 12m square you are having with a negative sign. So it will be minus 6m plus 2m, right? So it will be 4m square minus 6m plus 2m minus 3 is equal to 0. I hope this step is clear to everyone. Now take 2m common. So it will be 2m minus 3 plus 1. There is nothing common. So take 1 common. 2m minus 3 is equal to 0. Or 2m minus 3 into 2m plus 1 is equals to 0, or 2m minus 3 is equal to 0, or 2m plus 1 is equal to 0, or m is 3 by 2 here, m is minus half here. So you have got all the roots. First root is minus 1, second root we got m is equal to 2, and the third and the fourth root. So let us write all the roots together to write our yc. So we have the root minus 1, the root 2, 3 by 2, and the root this. These are the 4 roots of this biquadratic equation. Okay, now all we have to do is, referring the pattern of these roots, what are the pattern, what means, I mean to say, what referring the nature of these roots, we need to write the solution for yc, I mean the general solution of this differential equation. Now see, the roots are real and they all are distinct. So you must write yc is equal to, use the different constants c1, c2, c3, c4 and use your exponential functions, okay, and write your yc. It should be c1 e to the power the first root into x minus x you will get, plus c2 into e to the power the second root of the equation into x, plus the third constant into e to the power, that c3 into e to the power the third root 3 by 2 into x, okay, plus the final root is minus half. So c4 into e to the power minus half into x. This is the complete solution of this problem. I hope it is clear to all of you. Now let us continue with the homogeneous equation, solution of homogeneous equations subjected to certain constraints. We'll see those and then we'll continue with non-homogeneous differential equations. Stay tuned. Now let us continue with the solution of homogeneous differential equation subjected to the conditions. Now there will be a homogeneous differential equation like this, along with the conditions will be given through which, yeah, they satisfy, the solution of this differential equation satisfies these two conditions. So you have to work for the solution of this equation, okay. So it is as same as what we have done before, okay. Until you write your yc, it is same. After that, you have to use these values given to you and work for the constants c1 and c2. Okay, I'll show you how to do that. The solution is simple. See, once again you write, since y double dash represents d square y by dx square, y dash represents dy by dx. So every d by dx you have to replace by capital D. Is it not? So you have to write this as d square plus 4d plus 4 of y is equal to 0. Is it not? This is the given equation to you. Okay. Now consider the bracket. Replace every d by small m and write your auxiliary equation. So the auxiliary equation is m square plus 4m plus 4 is equal to 0. Okay. Now this is as good as writing m plus 2 whole square is equal to 0. Right? Or m plus 2 is equals to 0, or m is equal to minus 2 twice, because you see m plus 2 whole square is equal to 0. Whole square is 0 means m is equal to minus 2 is appearing twice. So the two roots are minus 2 comma minus 2. These are the two roots of this differential equation, the auxiliary equation. Once you find the roots, since these two roots are real and equal, follow the pattern for writing your yc. So yc should be written in the form, yes, first c1 independent of x plus x into c2. You accompany a x with c2. Take a bracket for them because they are repeated. Yes, there are only two roots. So two terms in your solution. E to the power, the value of the root into x. That is minus 2 into x. Now we got the solution. This is yc. Okay, that is complementary function I have told you before. The solution of a homogeneous differential equation is also called the complementary function, but actually it is the general solution of a homogeneous differential equation. Okay, now according to the given conditions to us, what it says, y of 1 is equal to 0 means you are going to put x is equal to 1 right here. When x is equal to 1, y is equal to 0. So put x is equal to 1 here. So it is 0 is equal to c1 plus x is equal to 1. So c2 as it is into e to the power minus 2 into 1, which is e to the power minus 2. Or this implies c1 plus c2 into e to the power minus 2 is equal to 0. Now e to the power minus 2 is a constant value. What is e to the power minus 2? E to the power minus 2 is 1 divided by e to the power 2. Right? Now this can't be 0 because e value is 2.718 whole square. E to the power minus 2 is, it is something like this. So it is never 0. What should be 0? You should have c1 plus c2 to be 0. So from this equation, this implies c1 plus c2 is 0. This equation you get. Okay. After that, you are given with another condition. What is that? Y dash of 1 is equal to minus 1. Right? So y dash means dy by dx. That is, you are going to differentiate this solution with respect to x. Okay, now don't confuse with that y dash and this yc. The solution, actually the general solution of homogeneous differential equation is also called complementary function. We write it as yc, but actually we can write it as y also. Okay, so differentiate this with respect to x and simply denote it as y dash is equal to, I am going to use u into v rule. First keep the bracket as it is. Differentiate e to the power minus 2x. So it will be minus 2 into e to the power minus 2x. Okay. This is the derivative of the exponential term. Now we should differentiate the bracket keeping e to the power 2x as it is. Differentiating this c1 with respect to x, it will be 0. Differentiation of the second term, it will be c2. Okay. Now it's given that when x is equal to 1, y dash is minus 1. It's given to you. So let's use it here. So minus 1 is equal to, put x is equal to 1 here. It is c1 plus c2 because x is 1. So it will be c1 plus c2 minus 2 into e to the power minus 2. Okay. Plus e to the power minus 2 into c2. It will be something like this. Now further if you simplify, it will be minus 2 into e to the power minus 2 c1. Multiply this over here. Plus, minus 2 into minus plus this. So it will be minus 2 into e to the power minus 2 c2 plus c2 into e to the power minus 2. Okay, you will get it something like this. Now you can take e to power minus 2, or you can simplify the two terms over here. Minus 1 is equal to minus 2 into e to power minus 2 c1 minus e to the power minus 2 c2, because minus 2 times this term plus 1, I mean plus 1 times this. You can take e to power minus 2 c2 common, you will get minus 2 plus 1, so it will be minus e to power minus 2 c2. You will get it something like this. And from this equation, look at this equation, c1 plus c2 is 0. So what is c1 from here? It is minus c2, right? So let us replace it by this. Yes, so you get minus 1 is equal to minus 2 e to power minus this, c1 is equal to minus c2, or c2 is equal to minus c1. So I will replace c2 is equal to minus c1 because already I have written c1. So if I write minus c2, so it will be e to power minus 2, c2 value is minus c1, write it here. Okay, so now minus 1 is equal to minus 2 e to power minus 2 c1 plus e to power minus 2 c1 you get. If you add the two terms here, you will get minus e to power minus 2 c1. Okay, so this implies c1, okay, you are having minus e to power minus 2 c1 is equal to minus 1 at the end. If you simplify this, c1 is equals to minus 1 divided by minus e to power minus 2. These two gets cancelled, e to the power 2. You get c1 as e to power minus plus 2. c2 will be minus e to power. So what should be c2? c2 is minus times c1. So it will be minus e to power minus 2. So let us substitute the values of c1 and c2 in this solution. So c1 you have got it to be, yes, this way. So substitute it here. So it is e to power 2 plus, but c2 is negative, right? Negative times e to power minus 2. So it is minus x into e to power 2. Sorry, not minus 2, it is plus 2 here. Okay, e to power 2 into e to power minus 2x. Okay, you can further simplify it as you want. Okay, or I can write the final solution as yc is equal to, or y is equal to, this is not a general solution now, because we are getting a particular solution or exact solution of this differential equation. Why? Because we are subjected to conditions we are solving. We do not have any arbitrary constants here. Okay, so we will directly write the solution here as 1 minus x into e to power 2 into e to power minus 2x, or 1 minus x into e to the power, you can take 2 common, 1 minus x. It is something like this. This is y. This is the complete solution of this differential equation. Okay, I hope it is seen there properly. Okay, let's continue in my next session. Few more problems on this. Okay, thank you.